Assalamu alaikum, dear students. Today's topic is law of conservation of momentum. Very important question from board's point of view. This is given as a long question, and its applications could also be given in the paper. So let's see what this law is about. It's law of conservation of momentum, and it states that, first of all, you are to tell the statement of the law. And the statement is the momentum of an isolated system of two or more than two interacting bodies remains constant. This is the statement of the law. Now, what is an isolated system? First of all, system is a group of bodies within some you can say within some boundaries. A system is a group of interacting bodies which are interacting with each other. An isolated system is a special one. It's a group of isolated bodies, it's a group of interacting bodies on which no external force is acting. No external force and no unbalanced force is acting. Okay. So the momentum of an isolated system, if you are having an isolated system, a system on which no external force is acting, the system could be a system of two balls. The system could be of rocket and gases which are inside it. The system could be of a balloon and the gases which are filled in the balloon. The system, you can give the example of a bullet and a gun. Okay, so we will be considering the system on which no external force is acting, and we will say that this is an isolated system. Okay, now the next line, two or more than interacting bodies. From here we are knowing this thing that it's not necessary that there are only two bodies in the system. There could be more than two bodies too. Okay, and the momentum of such a system which is isolated and which are interacting with each other, the momentum will remain, always it will remain constant. Okay, so this is the law of conservation of momentum. This was the statement. Now we will take different examples to understand this. You can see an isolated system here. In this isolated system, you can see a balloon which is going up, and the air is coming out of the balloon in the downward direction. This is an isolated system because there are only two things. No third thing is putting any external force on it. No unbalanced force. You can also give this example in third law of motion, in which you can see that the gases or the air which is coming out, this is action, and the balloon is going in the forward direction. This is reaction of the balloon. Okay, so we will say that momentum of this isolated system in which there are two interacting bodies, it will always remain same. How it will remain same, I will be proving this thing in the my upcoming examples. Okay, so this was a very simple example showing the conservation of momentum. Now let's prove it mathematically that this always remains same. Now in this simple figure, you can see there are two objects. One is A and one is B. The object A is having mass m, and it is moving with some initial velocity that is u1. And the object B is heavier one. It is having mass m2 and its velocity is u2. Now this is the picture before collision, before striking, before they are colliding with each other. But what happens after collision? You know that when these objects will collide or strike with each other, there will be a change in velocities. So the velocity of yellow ball will be v1 instead of u1. Okay, and the velocity of the second object, the blue object, will be u2. It was previously u2 and now it will be equal to v2. First, the direction of collision is shown by these two arrows, which are showing the direction that they are colliding with each other. And after collision, their direction has been changed and they are going in the other direction. Okay. Now the question is why U1 and U2 and V1 and V2, you know, when there are initial velocity and final velocity, we put I and F with them. We show the initial velocity with VI and the final velocity with VF. In the same way as there are four velocities, two before collision, U1 and U2, and two after, sorry, and two after collisions, V1 and V2. So to differentiate all these velocities, we use the terms U1, U2, V1 and V2. Okay. Now, the conservation of momentum. As I've told you that momentum is conserved in a closed, isolated system, this means that the initial momentum of the system must be equal to the final momentum of the system. If it remains conserved, if the momentum is not changing, then what does this mean? It means that initial momentum of the system is always equal to final momentum of the system. And in easy words, I can write Pi is equals to Pf, and this is the law of conservation of momentum. Okay. Now, M1U1 is the momentum of the yellow ball before collision. M2U2 is the momentum of blue ball before collision. And the sum of both of these momentums, that means the momentum before collision, that is equal to momentum after collision. As you know that momentum is the product of mass and velocity, it matters not whether the velocity is represented by u, v, x, y, it matters not. The concept should be clear that M1 U1 is the product of mass and velocity. M2 U2 is again the product of mass and velocity. And the next two are also the products of mass and velocity. And in the next part, I have written down very clearly that what was M1, obviously the mass of first object, which I've shown with yellow color, the yellow ball. M2 is the mass of second object, the blue ball. U1 is the initial velocity of the first object. This could be ball, this could be balloon, this could be any object. That's why I've written down the first and the second object. And V1 and V2 are the velocities of first and second object. Okay. Now let's consider this example about which is showing you the law of conservation of momentum in more detail. Uh, First of all, I have written down the statement: the momentum of an isolated system of two or more than two interacting bodies remains constant. So the initial momentum of M1 is M1U1. The initial momentum of M2 is M2U2. And the total momentum before collision, total means you are to add the momentum M1U1 plus M2U2. And this thing is shown with in the simple figure. This is before collision, this is after collision, and there is a change in direction after collision. Now the after collision momentum is shown. A final momentum of M1 is M1V1 and final momentum of M2 is M2V2. And total momentum after collision is equals to M1V1 plus M2V2. Now, according to law of conservation of momentum, initial momentum is equal to final momentum. And this is the mathematical form of law of conservation of momentum. If instead of two bodies, there are three bodies, then you can write plus M3, U3, and here after collision, you can write plus M3, V3, and so on. Okay. Now, again, the same thing is shown. Consider the following case of two balls that are colliding with each other before collision: M1, V1, M2, V2, or This is shown with V1I. You can write U1 here, you can write U2 here. Again, the example is same, okay? Now the applications of law of conservation of momentum. This is a very important example which is given on page number 70 of your book. And on page number 70, the last paragraph is showing this example. Write down very important with this, because this could be given in exams. Very important question. So I'm making you clear this example. This is a system of bullet and gun. Okay, this is an isolated system, and small m is the mass of bullet and small v is the velocity of bullet when there is no firing. The firing is not done up to now. Okay, and big M is the mass of gun and big V is the velocity of gun. Okay, small n and small m and small v are for the bullet, big M and big V are for the gun. Okay, now you can see this thing in the figure. Small m, small v for bullet, big M and big V for gun. This is the recoil force on the gun. You know, when the bullet is fired, the gun recoils back with a jerk. Gun comes back with a jerk, and that is known as recoil of the gun. Okay. Now, according to the law of conservation of momentum, the total momentum of the gun and bullet before the gun is fired, you can say before collision. So before firing, that is equal to 0, because before firing, the gun and bullet both are at rest. So in the formula mv, when you put velocity is equals to 0, you will get 0 on the left hand side of the equation. Now, when the bullet is fired, when the bullet goes out of the gun, that is the total momentum of the gun and the bullet when the gun is fired after collision means that is equal to big MV plus small mv. Now, according to the law of conservation of momentum, initial momentum is equals to final momentum. Then you know that initial momentum is equal to 0. So you will put 0 here, and final momentum is mv plus mv. You have written down here mv plus small mv. Now, if I take mv on this side, then there would be a minus sign. I will place a minus sign, a negative sign here. And if I want to know the velocity of recoil of the gun, then this big V is equals to minus mv divided by m. Here, sorry, this is big V is written, this is m. This V is m. Instead of V, you will write here m. Okay. So the formula for recoil of the gun V is equals to minus mv small divided by big M. Okay, this is big M. Cut it and write down big M here. Okay. So by putting the values of these quantities like mass of the bullet, the velocity of the bullet, and the mass of the gun, by solving this, you can find the velocity of recoil of the gun. And the negative sign is showing that the bullet will go in the forward direction and the gun will recoil in the backward direction. Okay. Now one more application of the law of conservation of momentum is about rocket and jet engines. This is conservation of momentum and rocket propulsion. Okay, this example is given on page number 71 of your book, last paragraph. Okay, this is also a practical application which is showing that momentum is conserved before collision and after collision. Now the rocket gains momentum in this direction. And why the rocket gains momentum in this direction? Because the exhaust gases gain momentum in the opposite direction. One is action and the other is reaction. And so this is the end of the topic, which was law of conservation of momentum, a very important topic. Okay. And tomorrow we will study the topic friction.